Look. We know this left-hand side equals right-hand side. One polynomial times another plus 61. This is true for any values. You plug in any x here, it's going to be true. Okay. Now, this is a little bit generalized expression for that. Since this is true for any value of x, then we may plug in 3, see what's going to happen. Okay? If you plug in 3 right here, this x is replaced by this 3, and this x is replaced by this 3, replaced by this 3. This x is replaced by this 3. This x is replaced by this 3. They should be equal. Okay? Since this is true for all the x. Of course, you may plug in, replace x with 4, 5, 10, -1. But here I like to replace x with 3. The reason I'm doing so is because I know 3 minus 3 is going to be 0. If this one is 0, then 0 times this big quantity, whatever it is going to be 0. Okay? 0 times the big quantity is 0. Plus 61, I know right-hand side will only be 61. Okay, will only be 61. Left-hand side, you plug in, you have 2x, 2 times 3 cubed. 3 cubed is 27. That's 3 times 3 times 3. So you have 27, and then times 2, you have 54. 4 times 3 is 12. -5, you copy it down here. 54 plus 12, that's 66. 66 minus 5 is 61. So you can see right here, they are equal, 61, 61. Okay, let's see, things get a little bit abstract right here. You see, upstairs is actually this one. And then you replace this one with 3. It's actually you plug in 3 here, you replace every x with 3. So it's actually f3. Okay, f of x in this case, x replaced by 3. So you know f3 is actually this one. f3 equals 61. Again, the right-hand side is similar. This one replaced by 3, 3 minus 3, 0, times q of x. Q of x was this one. And then q of 3 is a big number, but here is 0. So you get 0 times q of 3 is still 0. Replace this x with 3, but you know q of x is 61. That's the quotient. That's the remainder. You see, remainder 61. So here 61 is actually remainder. So any x, r of x is 61. You plug in 3, you still have 61. So 0 plus 61, you have 61. Okay. Now, this basically tells us what? f of 3 is 61. That's important. f of 3 is 61. That tells us what? Is 61 a remainder? This tells us f of 3 is the remainder. That's important and interesting. Remainder of what? F of x, this one, divided by x minus 3, this one. Then the remainder is 61. 61 is f of 3. F of 3. You see here 3, here 3. So in general, f of x divided by x minus c, c stands for a constant, is in our case here is 3. Okay, so then the remainder is f of 3. Then the remainder here is f of c. You see here are the same. C here, C here. So this theorem is called remainder theorem. Okay, how are we going to calculate f3? We plug in on the left hand side. See, f of 3 equals that, 61. That's the remainder. Okay, so we don't need to do this division. We plug in right here, then we know whatever it end up with, it will be the remainder. Okay, f of 3 will be the 61 will be the remainder for x minus 3. Here 3, in general, if here is 4, here will be 4. If here is 5, here will be 5. Remember, it's always x minus. And here c, here c. Okay? So that's the theorem. I'll see you next time.